Hi there, welcome to www.highschoolmaths.co.uk. Today we're going to be looking at calculating standard deviation. I'm going to be using method 2 for the calculation this time, which means we're using a slightly different formula. Now, we'll end up with the exact same answers, but the working going through this is going to be slightly different, so this may be more like what you've seen already if you've covered it in class. So the formula we've got here is, I'll just explain that just now. So I'm going to move this over so we've got a little bit of space to work with. Okay, and there's a few things in the formula we need to know. So we've got the sum looking kind of sigma notation, which means sum of or total. Okay, so that just means this would mean a total of the x squareds, and this is the total of the x's squared. Okay, so that's all that's really talking about. It's the fancy way of saying total. N, how many numbers we have in our data set, and SD just represents standard deviation. So that kind of covers everything we need to know here. Now, the good thing about using this method over the other method, method 1, which there's already a video for, is this method doesn't require the mean. Okay, so you don't need to calculate the mean for this method for part A. So let's not go through part A. What we need is the total of the x squareds minus the total of the x's squared. So we're going to do a table. Our table is going to be fairly straightforward. It's going to have x's and x squareds. We're looking for total of the x's for this one. We're looking for total of the x squareds for this one. Okay, so for the x's, we've got 32. This is just all our data, 40, 35, 25, and 30. For the x squareds, we're just squaring each one of these numbers. So we get 1024, 1600, 1225, 625, and 900. Okay, now at the bottom here, what we want to do is total both of these columns. Okay, so we want the total for the x's, which ends up being 162, and the total for the x squareds, which is 5374. Okay, I'm going to label that just so it's clear which one's which. This is the total for the x's, so this is the sum of the x's, and this is the sum of the x squareds. Okay, and that'll help when you substitute it into your formula. Now that part's a little bit easier than the previous using the other formula, but this part's a little bit trickier when you actually come to use the formula. So we've got the formula. Standard deviation is the sum of the x squareds minus the sum of the x's squared over n, all over n minus 1. Okay, so there's a little bit more work involved in the substitution part here. The sum of the x squareds is this one. So it's 5374 minus the sum of the x's in the bracket, so 162 in the bracket, squared all over n. And then we're going to divide that by what n? N is 5, there are 5 numbers. Let's go back and change that. So, all over 5, because there's 5 numbers. And in the bottom line, we've got n minus 1, so we get 5 minus 1. That's one big square root sign for that. Now, if you type that into your calculator and type it in carefully, you should get the square root of, for the top line, 125.2 all over 4, which gives you the square root of 31.3, which is 5.59 to 2 decimal places. Okay, so that is how you calculate the standard deviation. So the standard deviation here is 5.59, and let's have a look now at question B. Okay, so that's part A, asks us to calculate standard deviation. So that's us finish that part. Part B. So moving on to part B, I'm going to try and squeeze that in down here. So it says the mean price of a different brand of crisps was 26 pence and the standard deviation was 2.1. Make 2 valid comparisons between the 2 brands. Okay, so I'm going to bullet point these 2, so it makes it easier. Normally they're worth 1 mark per bullet point. So you're looking to compare, first of all, the mean and then the standard deviation. Now, the problem with this is for part A, we didn't actually have to calculate the mean because this formula doesn't need the mean value. Okay, now the mean in standard deviation questions is typically represented by a little x bar. Okay, so what I'm going to do is I'm going to calculate the x bar here, which is the mean. And that's just the total of all these numbers. So adding all these numbers together and then dividing by how many there are. Okay, so if we add them together and divide by how many there are, we get 162 divided by 5, which is 32.4. Okay, so for the first set of crisps, the first packet of crisps, we're looking at 32.4 pence on average. For the second pack, we're looking at 26 pence. So you compare them and make a little statement about your comparison. So we're talking about averages here. Okay, the mean is measuring the average. You've got to translate that rather than using the word the mean. And you can't just say the mean is lower or the mean is higher. You've got to actually make a statement that would make sense in a kind of global scale. So we're looking to use the word average. I would try and start my bullet point with that. So let me just move this down so I've got a little bit more space. So on average, and that kind of starts you off on the right path. You've already mentioned that you're talking about an average. I would say you're either comparing the first to the second or second to the first. So I'm going to say the first packet of crisps was more expensive than the second packet of crisps. Okay, so that's my statement. Now I could say on average, the second packet of crisps was cheaper than the first packet of crisps, and that would be fine as well, as long as you keep it consistent with the results you've got. And we're also looking for a numerical comparison here. So we're saying, okay, so 32.4 pence is bigger than or is greater than 26 pence. Okay, just to actually show that we've compared those two values. The next thing is looking at the standard deviation. So the standard deviation for our first one was 5.59, for our second is 2.1. The bigger the standard deviation, the more spread out the values are, the more varied. Okay, so that's what we're looking to communicate. Again, I'm going to compare first to second. If you want to do it the reverse, that's fine. Just make sure you change your statement appropriately. So we're going to say that the price of the crisps, the price of the first packet of crisps was more varied than the prices of the second packet. That's the kind of statement we want to go over. So the prices of the first packet of crisps were more varied than the second. And that's because 5.59 is greater than 2.1. Okay, so we're comparing this value and this value here. Okay, and again, you could say the price of the second packet was less varied than the first, and just flip that and then make sure you write the correct statement at the end. It's up to you how you want to compare first to second or second to first. As long as you do it in the context of the question, that's fine. And that's the real kind of common thing people miss out. Make sure you always relate it back to the information in the question. You've got to keep it relevant. If it's talking about prices of packets of crisps, relate it back to that. If it's talking about bacteria or anything else like that, or number of cows on a farm, I don't know. But always relate it back to the question. Make sure you are tying it in with the question. That's what it's really looking for, is that real life kind of context coming into play there. Okay, so that's your second way of calculating standard deviation. Hopefully you found that useful to work through. And if you've not seen either of the ways before, then hopefully seeing both of them will let you choose which one you prefer. As you see, both of them give you the exact same answers, so they are entirely equivalent. So some people prefer the first, some people prefer the second. So go whatever one you feel more confident with. If you would like some other maths videos and resources, please remember and visit www.highschoolmaths.co.uk. If you like the video, don't forget to click that like button and subscribe. And please remember and share this video with your friends. Thanks for watching and have a math magical day.